today's session will be on permutation and combination. So all those doubts that you people have about what is permutation, what is combination will have to end today. Okay. So to start with, permutation and combination depends on two pillars. That is rule of OR and rule of AND. Rule of OR and rule of AND. What does OR signify? OR signifies addition operation, whereas AND signifies multiplication operation. For this, for you to understand this, let me help you out with a small scenario where a person had to travel from village A to village C, and there was a village B in between. Okay, there was a village B in between. Now, there were two routes to travel from A to B and three ways, that is three routes to travel from A to C. But this person, he has to travel from where to where? He has to travel all the way from A to C. A to C. Now, let me call this way as to be X and this has to be Y. This has to be P, Q and R3 respectively. Okay. Now, when this person wants to travel from A to B, he can either go by X or Y. Look at the conjunction that I'm using here. He can go to B via X route or via route, via Y route. So, how many different ways can he go? He can go in two different ways. Now, from B to C, he can either take route P, route Q or route R. So, how many different ways he can go? He can go in three different ways. Yes. Now, but he has to travel from where to where? He has to travel from A to C. He has to travel from A to C. So, what will he do? He will take route X and route P, or route X and route Q, route X and route R. So, what is the conjunction that I'm using, guys, here? I'm using AND in between. So, AND signifies what? Multiplication. So, to reach from A to C, in how many different ways can he go? He can go in 3 into 2, 6 ways. He can go in 6 ways. Yes. Now, our formulas are there. What are they? NPR. We know NPR is equals to n factorial divided by n minus r factorial. I hope everyone knows this. Yes. The other formula that we have, NCR. NCR is equals to n factorial divided by n minus r factorial into r factorial. This is the second formula that we have. Yes. Before we move to the formula, let's understand in detail with an example, what do we mean? What do we understand? What do we mean when I say permutation and what do we mean when I say combination? Okay. Let's say there are two cricket teams to be formed. I will call the team 1 has to be team 1, the other team has to be team 2. One has to be team 1 and the other one has to be team 2. There are 15 people in a squad. How many people are there in a squad? In a cricket team, 15 people are there in a squad, but there are 11 playing. How many will play? 11 will play and there will be how many extras? 4 extras. Now, let's say for team 1, I had to select Yuvraj. First I chose Yuvraj first and then Dhoni next, and 8 other people and Kohli in the end. Those of the Kohli fans who might have got hurt, do not get worried. Now what will I do? Now this for the team 2, I will select Kohli first, 8 other players and UV and Dhoni in the end. Now what did I do? I chose UV first here, Dhoni next, 8 other I chose and then Kohli in the end. For team 2, I chose Kohli first, 8 other players, UV and Dhoni in the end. Yes. Now, what is the value here? Value is team. Upon changing the order of selection, did the value change? Did the team change? No. The team still remained the same. Yes. Do you agree that the team still remained the same? Yes. Do you agree, everyone? Do you agree that the team still remained the same? Yes. Now, upon changing the value, upon changing the order, if the value doesn't change, it is nothing but selection. What is it? It is selection. Yes. Now let's take up another scenario. Listen carefully. Everyone understood what is selection? Everyone understood? Are you sure, guys? Please reply in the chat box. Let me know if you could not understand. Those of you in the YouTube and also in the Zoom. Yes or no? I want to hear I in the chat box from everyone if you could understand. AYE. Am I loud and clear? Yes. Okay, great. This is about selection. Now, let's move to another scenario and understand what is arrangement. Okay, the other part. Listen carefully, listen carefully. Now, I'm talking about batting lineup. What am I talking about? Batting lineup. What is batting lineup? What do we decide in the batting lineup? Who goes as an opener? Who goes as a pinch hitter? Who goes as a tail ender? This is what we decide. Yes or no? Now, let's say there was on batting lineup 1 and batting lineup 2. Batting lineup 1 and batting lineup 2. In the batting lineup 1, what I did is I selected UV and Dhoni as an opener, and 8 other fellows, and then Kohli as a tail ender. Now, for the team 2, for the batting lineup 2, what I did is I chose Kohli as an opener, 8 other players, and UV and Dhoni is the tail enders. Now guys, I'm talking about batting lineup. What is my value here? My value is batting lineup. This is my value. Upon changing the order, did the value change? Answer me in the chat box. Did the value change upon changing the order? Yes or no? Did the batting, is UV and Dhoni going as an opener and UV and Dhoni going as a tail ender? Is it same? No, it is not same, because they are going here as openers in batting lineup 1, but here they are going as tail enders. It is not same. So upon changing the order, if the value, that is batting lineup, here it is batting lineup, if the value changes, it is called arrangement. But do I have to stop here? Start thinking. Guys, did I do the arrangement only here? No. Why? Because without choosing the playing 11, okay, out of the total of 15, can I arrange them according to the batting lineup? Without choosing the playing 11? No, I cannot do that. First, what is that I need to do? I need to select the playing 11 and then align them according to their batting lineup. So what did I do? I selected 11 out of total of the 15. So what did I do here? I did selection first and then arrangement, and then I arrange them according to their batting lineup. So this is the basic difference between selection, that is, I can also call it as only selection and arrangement. Now, let's come back to the formula. Let's come back to our dear formula that we had here. Just pay attention. We know that NCR is nothing but what? Selecting R people out of total of N people. Yes, do you agree? What is NCR? NCR is nothing but selecting R people out of total of N people. In how many different ways can it be done? It can be done in N factorial divided by N minus R factorial into R factorial. Now, if I send my R factorial onto this side, observe what will happen. It will be NCR into R factorial. NCR into R factorial is equals to N factorial divided by N minus R factorial. Now, what is N factorial divided by N minus R factorial? It is nothing but NPR. So can I replace that? NCR into R factorial is equals to NPR. Can I replace this with NPR? Yes. Everyone able to follow? Now, what is NCR? NCR is selection. And multiplication represents what? Multiplication represents and. What does R factorial represent? R factorial represents only arrangement, or for now I can call it as arrangement. Only arrangement. Why it is only arrangement? I would like to say that R factorial is rather only arrangement. But why is it called only arrangement? In time to come, you will answer it to me. Okay? You guys will answer that to me. Okay? Now, listen to me carefully. Now, if NCR is selection and is represented by multiplication and R factorial is only arrangement, then what will be NPR? NPR is nothing but selection and arrangement. Selection and arrangement. So NPR is what? NPR is selection and arrangement. Guys, you have any doubt with respect to whatever is done till now? Any confusion? Anyone, any confusion with whatever is done till now? Be quick to ask for it. Anyone, any doubt? Anyone, any doubt? Nasreen, is the class comfortable? Is everyone comfortable with whatever is being done? Are you guys sure? Okay, then quickly take it down, and those of you who have doubt can have a personal chat with me while you are taking it down. Okay, last 5 seconds. 5, 4, 3, 2, 1. Yes, let's go live again. Now, I will deal with few of identities that we come across combinations. What are they? NC1 is equals to N. The other one will be NCN is equals to 1. And one more identity, NCR is equals to NCN minus R. We now know that NCR is nothing but what? Selecting R people out of total of N people. Now, let's understand NC1 is equals to N. Let's say there was a Kabaddi team of 7 people. Okay, 7 people. 1, 2, 3, 4, 5, 6 and 7. Now, one of them had to be crowned as a captain. Any one of them had to be crowned as a captain. Now, in how many different ways can you select the captain? It can either be the first person, second person, third person, fourth, fifth or sixth or seventh. Yes. So, now out of the total of 7, if we had to select one person, selecting one person of total out of the 7, in how many different ways can it be done? It can be done in 7 different ways. It can be done in 7 different ways. Selecting one person out of total of, let's say 9, in how many different ways can be done? Now, selecting 1 out of total of 9? 9. Be answering, keep answering. Now, let's say, understood this part? Let's move to the next one. Now, let's say let me take a scenario of a selection day where a Kabaddi team was supposed to be formed. 7 people Kabaddi team was supposed to be formed. It was your school day. Let's presume it's your school day. Okay. On that day, only 7 people arrived. Only 7 people arrived and all the 7 had to be taken into the team. All the 7 had to be taken into the team. Look, 7 people, out of total of 7 people, how many were supposed to be chosen? All the 7 had to be chosen. Like selecting 7 people out of total of 7 people. In how many different ways can it be done? It can be done in only one different way. It can be done in only one different way. Now, selecting 13 people out of total of 13 people. In how many different ways can it be done? It can be done in only one different way. Yes. Now, let's move to this one. What does it say? What does it say? Let's say I'll use 5C3 here. 5C3 or let me take 5C2. Okay. 5C2. Now, what does 5C2 mean? If I apply this formula directly, what does that give me? It will give me 5C3. 5C3. Now, to understand this, let me take this 5 has to be A, B, C, D and E. Yes. What am I doing here? Selecting 2 people out of total of how many people? 5 people. I'm selecting 2 people out of total of 5 people. So, I have 5 people here. Now, listen, I can select first 2, second 2, third 2, last 2 or first and the last. Yes, I can do this. But if you observe, when I'm selecting the first 2, what am I doing to the rest of the 3? Rest of the 3 I am rejecting. When I am selecting the first and the second, rest of the 3, that is A, D and E. What am I doing? I am rejecting them. When I am selecting first 2, I am rejecting the last 3. When I am selecting, let's say, last 2, I am rejecting first 3. So my number of selections is equals to what? Is equals to what? Number of rejections. What is it? Number of selections is equals to number of rejections. Okay. This part, everyone could understand the identities here. Everyone, all these identities. Are you okay with this? Now, let's move to the calculation part. Calculations I won't be dealing much because I think you must be knowing it by now. And if you do not know, please take up as many combinations as possible and try to solve them. Let's say I have 6C4. 6C4 is nothing but what? N factorial divided by n minus r factorial into r factorial. So now if I apply this, what will be it? 6 factorial divided by 6 minus 4 is 2 factorial into 4 factorial. Now, what does that need to do? Now, 4 factorial till 4 factorial, it will be cancelled. It gives me 6 into 5 divided by 2. 5, 2 ones, 2 threes. 5 into 3 is 15. Yes. Similarly, if I had 15C2, can I go directly to this step now? 15C, let me take it as to be 13. 15C, 13. Now, what will happen? I will be remaining with 15 into 14 here. 15 into 14 here. Next, what will be there here? N minus r factorial, that is 2 factorial will be there. Yes, everyone? Now, calculations are again simple. You will have to deal with them on your own. Yes. So, this was about the basics that we need to solve any question which comes to permutations and combination. Now, the first question of ours, let's get started with it, and it goes something like this. It says, form a committee of 7 members, okay? Form a committee of 7 members using 6 men and 5 women. 6 men and 5 women such that there are any 7. First clause I will take. There are any 7 members. You can select any 7 members. Selecting any 7 members out of total of how many? 6 men and 5 women. Totally together 6 and 5 is 11. Selecting 7 people out of total of 11 people can be done in how many different ways? Selecting 7 people out of total of 11 people can be done in 11C7 ways. 11C7 ways. Now, if the question is something like this, okay? Exactly 3 women. Exactly 3 women. Now, we'll deal with the language part first here. Exactly 3 women meaning what? There must be 3 women. Precisely there must be 3 women. But I have to form a committee of how many members? 7 members. If there are 3 women, how many men will be there? How many men will be there? There will be 4 men. 4 men. But what is the conjunction that I am supposed to use here in between? 3 women and 4 men will make me a committee of 7. Committee of 7. Rest is easy. Selecting 3 women out of total of how many women? 5 women. It can be done in how many different ways? 5C3 and represents multiplication. And selecting 4 men out of total of how many men? 6 men. It can be done in how many different ways? 6C4. 6C4. Following? Everyone able to understand? Once we write the language part, rest is cakewalk. Numbers we can deal with it. But cracking the logic, you must be able to do it with what? I suggest you do it with the language part because numbers are a little bit complicated, but the language part is very easy. Yes. Now, if I give you a statement something like this, it says exactly 3 men. Now, you guys tell me what are you going to do? What will be the language part? What will be the language part? Anyone? Nasima, Srishant, here in the YouTube side and everywhere, Zoom and YouTube, both of you. Just give me the language part here, guys. Exactly 3 men meaning 3 men must be there. How many women must be there? There must be 4 women. Now, 3 men and 4 women will make a committee of 7 members together. So, 3 men and 4 women together will make a committee of 7. So, this gives me how much? 3 men is nothing but what? Selecting 3 men out of total of 6 men. It can be done in how many different ways? 6C3 ways and represents multiplication. Selecting 4 women out of total of 5 women can be done in 5C4 ways. 5C4 ways. Yes. Now, let's say the question is something like this. Let's say, let me not take it here. I'll take it here rather. Okay. Let's say I'll take it here. 4th one. It goes something like this. At least 3 women. Start thinking. What am I doing here? The condition says what? Form a committee of 7 members using 6 men and 5 women such that there are at least 3 women. At least 3 women meaning what? At least meaning minimum of 3 women must be there. Minimum of 3 women must be there. Can the number of women be more than 3? Yes, of course. So, language part I will deal with it. 3 women are there. If 3 women are there, how many men will be there? 4 men will be there. Now, one type you can form it like this. Now, what do I write here? What is the conjunction I am supposed to use? The conjunction that I am supposed to use is or. 3 women and 4 men can form a committee of 7, or 4 women and how many? 3 men can form a committee of 7, or again 5 women and how many? 2 men can form a committee of 7. Now, should I move any further? No, I should stop. Why? Because there are only 5 women with me and I have to stop at 5. Rest is what? Rest is numbers. Numbers are easy. Let's go deal with it. 3. Selecting 3 women out of total of 5 women can be done in 5C3 ways and represents multiplication. Selecting 4 men out of total of 5 men can be done in 5C4, or represents what? Or represents addition, people. It represents what? Addition. Selecting 4 women out of total of 5 women, 4C4 into next. This will be 6C3 plus this will be what? 5C5. What do I write it? Quickly, anyone? 5C5. Can I write it directly? Has to be 1 because NCN is equals to 1, and represents multiplication, and selecting 2 out of total of 6 can be done in 6C2 ways. 6C2 ways. Yes, everyone able to follow? Now, let's move a step ahead and I'll tell you a different thing now. What is that? Now, at most 3 men, if I say at most 3 men. Now, I want you guys to proper text in the chat box with the language part. Everyone, can everyone do that for me? Can you guys do that for me? Quickly drop for language part for at most 3 men. Guys, come on. Who is going to the first one in the Zoom and the first one in the YouTube? Let me see. I've got my glasses for the same reason so that I can see your comments there. So please do not disappoint me. I want the answers, people. I want the answers. Venkatesh has come up with an answer. Was it for the previous one or this one? I do not know. Okay, let's get started. What will be the language part? At most 3 men, meaning at most. At most, I'm underlining at most. What does it mean? Maximum. Maximum, how many can be there? Maximum 3 men can be there. Srishant came up with an answer in the YouTube, and on the other side, let's see who will come up. Zoom. Zoom is still pending, guys. Come on. Yes, at most 3 men, meaning what? Maximum 3 men can be there. The number of men can be 1 as well. If there was 1 man, what will happen? How many women are there? 5 women. But I cannot form a committee of 7 using 1 man. So, minimum number of men should be how many? Minimum number of at most 3 men, maximum 3. But the men must be minimum of 2. If 2 men are there, and 5 women are there, I can still form a committee of how many? 7. Or 3 men and 4 women can form a committee of 7 for me. At most 3, maximum 3 are there. So these are the only 2 cases. Can I move further? No, because maximum is 3. Maximum is 3. So who came up with the right answer? Sir, is that correct? 5C44, because there are 6 men. Where is it? Okay, this part. Okay. It happens. Nothing here. There are 6 men. I accidentally wrote. Okay, here. Everywhere else it is right. Only this one right. Okay, make a simple correction. Not an issue. Let's move ahead. Now, at most meaning what? Maximum 3. Can there be another case other than these 2? No. So what we'll have to do here? 6C2 into 5C5. 1 again, or represents addition. 6C3 into 4. Selecting 4 women out of total of 5 women can be done in 5C4 ways, and it is done. Now, tomorrow in your question paper, if there is a question on forming committee, will every one of you solve it? Yes or no? I want the answer now. Will you solve it if there is a question on forming committee? Yes or no? Yes. Well, guys. Well, if you have any doubt, ask it to me right now. And meanwhile, you can start copying it quickly so that we can move ahead. Okay, you have last 5 seconds. 5. Okay, it is done. Let's get started. Now, guys, Let's come down to forming numbers. Forming numbers. How many of you are already comfortable with forming numbers? How many of you are already comfortable with forming numbers? Okay. So here is a question for you. The question goes something like this. Using digits 3 and 5, form a 2-digit number. Form a number. Okay. I'll not specify anything. I'll just tell you that using digits 3 and 5, how many numbers can be formed? My question, I've reframed my question, everyone. Using digits 3 and 5, how many numbers can be formed? How many numbers can be formed? 35 can be formed, 53 can be formed, 33 can be formed, 55 can be formed. All of you stopped here? All of you stopped here? I presume many of you stopped here. But did I give you any condition? I just gave you two numbers and I asked you to form numbers. But you stopped here. Why? What is stopping you from taking a number 333 or for that matter 353 or for that matter 3 single digit 3? So how many numbers can I form using digits 3 and 5? I can form infinite number of numbers. I can form infinite number of numbers using digits 3 and 5. When no condition is given to me, I can form infinite number of numbers. But now I'll tell you that I have 3 digits, 3, 4 and 5. And I'll ask you to form a 2-digit number. This time I'll ask you to form a 2-digit number, and I'll also tell you another condition where you can not use a number, that is without repetition and with repetition. In your examination you will be asked either one of them. Do not panic. You will be asked either one of them, but I'm trying to solve both the cases. Now, without repetition, meaning what? The number you have used once, you cannot use it again. So what are the cases here? Just tell me. 34, 35, 43, 45, 53, 54. Any other number other than this? That's it. So how many do I have here? 1, 2, 3, 4, 5, 6. 6 I have here. In how many different ways can you form a 2-digit number using 3, 4 and 5 without repetition? You can form it in 6 different ways. Now if I ask you something like this. Now with repetition meaning all these 6 cases will go here as well. Meaning these 6 will come here for sure. These 6 cases will come here for sure. Other than these 6 cases, what are the 3 other cases that will pop up? One is you can write a 33. Another one is you can write a 44. The other one is you can write a 55. Very good. Now, so how many more? 3 more. 3 more you can write. 6 already were there. 3 more. So 9. 9 you can form. Now, this is for with repetition. This is for the small question. Now, if I shift ahead, if I move a little bit forward and I give you a question, something like this. The question goes something like this. Form a 4-digit number using digits from 4 to 9. How many numbers can be formed using digits from 4 to 9? Now tell me what will happen. The same case. One is without repetition, the other one is with repetition. Without repetition, and the other one is with repetition. Start thinking. What will you do? Now, to form a 4-digit number, how many blank spaces do you need? I need 4 blank spaces. To form a 4-digit number, I need 4 blank spaces. Can I start writing cases like this? Anyone who is going to support me write all those cases? So what will be the numbers? 4, 5, 6, 7, 8, 9. Anyone? Nasreen, will you help me today to write all the cases? Infinite number. Many numbers will come. We cannot write it. Will take a lot of time to write those. So how to deal with such type of questions? Listen carefully. I'll take up a small example here itself. Let's try to solve this one and understand and then implement our learnings into this question. Okay. Now, to form a 2-digit number, how many blank spaces do I need? I need 2 blank spaces. Here as well, I need 2 blank spaces. Do you agree? Now, start thinking. Without repetition, that is the number you have used once, you cannot use it again. So, in how many different ways can you fill this units place in? It can either be 3, 4 or a 5. In how many different ways can you fill this units place in? You can fill it in 3 different ways. Now, you have used one number among these three numbers, that is among these 3, 4 and 5, you have used up one among them. Let's say you used up 4. In how many different ways can you fill the tens place here? You can fill it in 2 different ways. 3 into 2, 6 ways. 6 ways, which is exactly what we have got here. Now coming to this one. Pay attention. Without repetition, we are done 6 ways. With repetition, what is the answer we are supposed to get? We are supposed to get a 9 there. So what will we do? Look, units place, it can be filled in how many different ways? It can be either filled in a 3, 4 or a 5. How many different ways? 3 different ways. Now, I can use the number that I've used. So how many different ways can I fill the second blank in? In how many different ways can I fill the second blank in? I can fill it in again 3 different ways. So 3 into 3 gives me a 9. So that is exactly as what I've got here. Now you guys are going to help me solve this question here, which says form a 4-digit number using digits from 4 to 9. 4 to 9, how many numbers do I have? I have 6 numbers. Without repetition case, guys, in how many different ways can I fill the units place here? In how many different ways? I can fill it in 6 different ways. Now, I've used up one number among these numbers. So, how many numbers will I be left out with? I'll be left out with 5 numbers. So, 5. Next, 2 numbers are used up. Next, 3. Yes? Able to follow everyone? Able to follow this? How I wrote this 6 into 5 into 4 into 3? Everyone? Anybody? Any doubt? Ping me right now in the chat box, guys. Come on. Anybody? Any doubt? Yes? Chalo. Let's move ahead. With repetition case, what will happen in the with repetition case? Now, I can use the number that I've used previously. So, how many different ways can I fill the blank here in? It can be either 4, 5, 6, 7, 8 or 9. So, I can fill it in 6 different ways. Let's say I've used up 8 here, but I can also use a 8 here as well. So, in how many different ways can I fill it? 6 different ways. Let's say I used up 8 at 2 places, but still I can use 8 here as well. So, how many different ways can I fill it? 6 again and 6 again. Yes? Yes? Able to follow everyone? Able to follow? Now, if I pose a question to you something like this, which says, form a 4-digit number, 4-digit, D-I-G-I-T, excuse me with the spelling, 4-digit number using digits from 1 to 9. Same thing I'll tell you. Then one is without repetition. First thing in your examination, either this will be asked or this will be asked. So without repetition and with the repetition. Now to form a 4-digit number, what does that we need? We need 4 blank spaces. I'll quickly draw 4 blank spaces. Here also I need a 4 blank spaces. Now 1 to 9. How many digits do I have? Quickly everyone. How many digits do I have from 1 to 9? I have 9. Yes, 9. So how many different ways can I fill the first blank in? 9 different ways. Next blank in, I've used up one number among the 9 numbers. So I can fill it in 8. Next one in 7. Next one in 6. So here what will happen? 9. I can use the number. So 9 again. So 9 again and 9 again. Yes. Able to follow everyone? Able to follow? Are you guys sure? Now let's move a step ahead again. Now this time I'll tell you to form, let's say, form a 4-digit number, 4-digit, let's not make it 4-digit even number. I'll say 4-digit even number using digits from 4 to 9. Using digits from 4 to 9. The conditions will remain the same. The one is without repetition, the one with repetition. So what will you do? To form a 4-digit number, okay, I need 4 blank spaces. Here as well and here as well. Anybody, any doubt with that? No, right? Yes. Now, what is the condition? Whatever the condition is in permutations and combination, whatever the condition is, we start with that condition. Whatever the condition is, we start with that condition. What is the condition here? It is even number. For any number to be an even number, what should be the criteria? What is the prerequisite? That the number in the units placed must be an even number. The number in the units place must be an even number. So what are the even numbers from 4 to 9? 4 to 9, what are the even numbers? 4, 6, 8. So in how many different ways can I fill the units place here? I can fill it in only Three different ways. Why did I replace it with 3 here? Start thinking. From 4 to 9, how many even numbers do I have? I have 4 and a 6 and a 8. So for any number to be an even number, in the units place, it must have even number. So this 3 here, guys, this 3 here is 3 ways I can fill it. It is talking about the number of ways. So one way, second way, third way. So 3 different ways. So now, out of the total of 6 numbers, I have used up 1 number. So how many numbers will I be left out with? I'll be left out with 5. Now 2 I have used up, 4. Next, 3. Following, everyone, anybody, any doubt? Now, units place, again I can fill it in 3 different ways because it has to be an even number, the condition says. Now, with repetition meaning what? I can use the number that I've used in units place again. So 6 numbers, I can fill it in 6 different ways, 6 different ways and 6 different ways. Yes, able to follow everyone? Anybody, any doubt till here? Till here, let's move to the next question then. Okay, next type of question. We'll get familiar with every single different type of question that we come across, permutations and combinations. Let's see, we'll go step by step, stay connected, stay focused, have a pen and paper and be interactive. The only thing is you have to be interactive. Okay, now let's have a look at the next question. Form a 4-digit number. Again, the question will be, form a 4-digit number greater than, I will say 5,000. Greater than 5,000. Using digits from 4 to 9. Again, 2 cases we will solve always, without and with. So you guys have to help me now. Tell me, to form a 4-digit number, how many blank spaces do I need? 1, 2, 3 and a 4. Here as well, 1, 2, 3 and a 4. Now, start thinking. A number, where do we start in permutations and combinations? Guys, whatever the condition is given, we start from there. What is the condition in this question? The condition is the number must be greater than 5,000. So, where do I have to start with? From the units place or the thousands place? Where do I have to start from? From the units place or the thousands place? Quick. Decide now. It is the time to decide. I have to start from the thousands place. I have to start from the thousands place. Now, if I start from the thousands place, what are the numbers? 4 to 9. 4, 5, 6, 7, 8 and 9. For any number to be greater than 5,000, it should have what? It should have what? It should have 5 or a number greater than 5 in the thousands place. Yes, it should have what? 5 or a number greater than 5 in the thousands place. So how many different ways can I fill it? 1, 2, 3, 4 or a 5. So I can fill it in 5 different ways. I can fill it in 5 different ways. Now I have used up one number among these. How many? 6 numbers. So how many numbers will I be left out with? 4. Next one, 3. Next one, 2. Yes? Yes? Now, start here. What will I do with repetition? Now, I can fill it in 5 different ways, but I am allowed to use the number that I have used. So, I can fill it in how many different ways? So, 5 different ways. So, I will be left out. Okay. This one I made a mistake, I presume. I can fill it in 5 different ways, but I will be left out with how many numbers? 1, 2, 3, 4 and 5. So, I will be left out with 5 numbers, guys. Nobody corrected me in that meanwhile. What are you guys doing? Sleeping, huh? Look, I can use one number among these 5 numbers to fill the thousands place. But I've used up how many numbers out of total of 6 numbers? 1 number. So how many numbers will I be left out with? I'll be left out with 5 numbers. So I've used up 2 out of 6 now. How many numbers will I be left out with? 4. Next one, 3. This is the right answer. Yes. Now come to me here. Come to me here. I can fill the thousands place in how many different ways? 5 different ways. Next one in how many different ways can I fill it? I can again fill it in 6 different ways. Why? Because I can use the number that I've used here. So 6 into 6 into 6. 6 into 6 into 6. Yes? Now, there is a question for you and a brief time to solve it and then to copy it as well. So have a look at the question and try to answer it. Everyone. Okay? form a 4-digit number using digits from 0 to 9. Both the cases, one is without repetition, the other one is with repetition. So by the time after you are quickly done with copying this, whatever is on the screen, you quickly go and attempt this, or you attempt this now and then try to copy whatever is on the screen. Okay guys, I'm giving you a minute to win it. Let me see who answers it first in the chat section. I'm here. Look, there are 4 blank spaces to form a 4-digit number. Guys, pay attention. Everyone who was trying to solve this, get back to the screen. Stay hinged. Look, 4 blank spaces to form a 4-digit number. Now, 0 to 9, how many numbers do I have? First question of mine to everyone who tried solving it. So, if you have tried solving it, you must be knowing at least something. So, be responsive in the chat box. So, how many numbers do I have from 0 to 9? How many numbers do I have from 0 to 9? I have 10 numbers. Now, is there any condition given in the statement? My next question is there any condition given in the statement? Yes, there is a condition is given in the statement. What is that condition? 0. Whenever you see a 0 in the statement, 0 itself is the condition, guys, because we are trying to form a 4-digit number, and I'm repeating again, I cannot have a 0 in the thousands place. If I have a 0 in the thousands place, what will it become? It will become a 3-digit number, guys. It will become a 3-digit number. So I cannot have a 0 in the thousands place. So start thinking. If I cannot have a 0 in the thousands place, this is without repetition. In how many different ways can I fill the thousands place in? I can either fill it with a 1, 2, 3, 4, 5, 6, 7, 8 or a 9. So how many different ways can I fill it? I can fill it in 9 different ways. Everyone pay attention. I can fill it in 9 different ways because I cannot use a 0. But come here now. Coming to the hundreds place. I might have used up one number among the 10 numbers available. But I have a 0 back now. Why? Because even if I use a 0 here, it will still be a 4-digit number. So how many different ways can I fill the hundreds place in? I can fill it in 9 different ways. So I've used up 2 numbers out of total of 10 numbers now. So how many numbers will I be left out with? 8 numbers. Now I've used up 3, so I'll be left out with 7. Now, with repetition case, pay attention. I can fill this in how many different ways? I cannot use the number 0, but I can use all the other numbers, so I can fill it in 9 different ways. Into, I can use the number that I've used here. So totally how many numbers do I have? I have 10 numbers. So I can use all the 10 here, all the 10 here, and all the 10 here. Yes, able to follow? So one thing that you have to remember when it comes to forming numbers, whenever you see a 0, 0 itself is a condition, dear class. Yes, everyone able to follow? Venkatesh? Guys, you answer something and then you retract it as if I have not seen it. Do not retract it. Let it be there. Be proud of your mistakes. Your mistakes are something like a scar on the warrior's face. A warrior is very proud about the scar on his face, isn't it? So you also be proud about it. You did a mistake, you learn from the mistake. There is nothing to be worried, guys. So quickly take it down. I'll be back in a minute. Okay, Sri Lakshmi has it out here. Form a 4-digit even number using digits from 4 to 9. Why without repetition? Why use 6 into 5 into 4 into 3? Okay, let me have a look at that. Without repetition, even, where is it? 4-digit even. No, it is even number case here. Without repetition, how many numbers do we have? 4 to 9, Sri Lakshmi? We have 6 numbers. Listen to me carefully, Sri Lakshmi. How many numbers do we have from 4 to 9? We have 6 numbers. Now, in how many different ways can I fill the units place in? I can fill it in 3 different ways, either using a 4 or a 6 or a 8. Either using a 4 or a 6 or a 8. Now, among those 6 numbers, I've used up 1 number. Let me say that I've used up 1 number. So, how many numbers will I be left out with, Sri Lakshmi? Answer in the chat. How many numbers will I be left out? I'll be left out with 5 numbers. So, I can fill, let's say, thousands place or tens place, wherever I can start with. But I can fill the thousands place in how many different ways? 5 different ways. Now, I've used up how many numbers? 2 numbers. One in filling the thousands place, one in the units place. So, how many numbers will I be left out with? I'll be left out with 4. Next is 3. Understood? Understood. Is that okay? Okay, guys. I'm live again. Now, arranging people. We'll start with arranging people. Everyone, pay special attention for another full attention for 5 minutes here, because this is very important. Okay, very important. In first question will be something like this. It will say, in how many different ways can 6 people be arranged in 4 chairs? 6 people be arranged in 4 chairs. What are we used to doing? We are used to doing, whenever the question says in how many different ways 6 people be arranged in 4 chairs, what do? We write NPR. NPR is 6P4. 6P4 is nothing but what? 6 into 5 into 4 into 6 into 5 into 4 into 3. Because I'll have 6 minus 4 is 2 factorial. I've eliminated it. I've written the answer directly by the formula. Yes, this is what we do. But using the method that we have learned, what? Arranging. How do we do that? How many chairs do we have? How many chairs do we have? We have 4 chairs. So let me place those 4 chairs. 4 chairs. Now start thinking. In how many different ways can this chair be filled? In how many different ways can this chair be filled? It can either be the first person, second person, third, fourth, fifth, or sixth. So I can fill it in 6 different ways. Now, one among those 6 people is sitting already. So how many people am I left out with? 5. Next, 4. Next, 3. Yes. I can also do it using the formula what? NCR into R factorial will also give me the same answer. Yes. Now, I'll change the question a little bit now. Pay attention, 100% attention. Why I told you? Listen. Look. 6 people, 4 chairs were there. Now this time I'll do what? 4 chairs and 6 people I'll give you. Okay. 4 people and 6 chairs I'll give you. Okay. Now what is that I do every time? I have to take down the chairs. 1, 2, 3, 4, 5, 6. I've taken down the 6 chairs now. Now 4 people are there, 6 chairs are there. Now these 4 people can occupy the first 4 chairs or the last 4 chairs or the middle 4 chairs or the first 2 and the last 2. Yes, this way they can do it. Yes, they can only occupy the first two and the last 2 or first 4 or last 4. Yes, anyways they can do it. Now, how do we deal when there is such type of a situation? What is that we do is, we imagine that these 6 chairs are inside a room. Okay, these 6 chairs are inside a closed room. There is a door here. Okay, and 4 people are waiting. 1, 2, 3 and 4. 4 people are waiting outside this room. When the first person walks into this room, in how many different ways can he sit? When the first person walks into this room, when he is walking into this room with his legs, how many different ways can he sit? He can sit in the first, second, third, fourth, fifth or sixth. In how many different ways he can sit? He can sit in 6 different ways. One among these chairs is filled now. Now the second person will start walking into the room. When the second person walks in how many different ways can he sit? 1 chair is occupied, so he can sit in 5 different ways. Next person, 3 different ways. Next person, 2 different ways. Okay. 4 different ways here. Okay, I'll strike it off here. First person he can sit in 6, next one in 5, next one when he goes 2 are occupied, he can sit in 4 different ways. Next one he walks in, he can sit in 3 different ways. Yes, but you might be thinking that, this question 4 people 6 chair, this question 6 people 4 chair, these are same. They are not same. They are not same. Why are they not same? Keep observing. Now, when the number of people are more than chairs, what did we do? We assigned people to the chairs. We assigned people to the chairs. We were assigning first person, second person, third person, or fourth, or fifth, or sixth. What were we doing? We were assigning people to the chairs. Now, what are we doing here? What are we doing here? Now, 4 people were there, 6 chairs were there. We were now assigning chairs to people. Chairs to people. What are we doing now? We are assigning chairs to people. Now, if you still could not understand, it is as simple as whatever is greater will be assigned to the later. Whatever is greater will be assigned to the later. Now, for others, for different, let me take up another scenario to explain it to you. Okay. Now, let's say I have a parking slot. Okay. 1, 2, 3, 4, 5, and this is 6. Okay. Let me call this as 1, 2, 3, 4, 5, and 6. Those of you who could not understand what happened here, just start thinking. When there are 4 cars here. Car 1, I'll call car 1. This is, okay, wheels you want, okay. Okay. This I'll do car 2. This is car 3, and this is car 4. Okay. When the first car moves to the parking lot, in how many different ways you can park? First way, second way, third way, fourth way, fifth way, or sixth way. How many different ways he can park? He can either park in any one of them. Once he parks up one of those places, let's say he took up this place. When the second car starts moving, in how many different ways he can park? All the other 5 other than this. So, first car can park in 6 ways, second car can park in 5, next one in 4, the next one in 3. That is exactly what I have explained it to you here. And remember, whatever is greater will be assigned to the later. Now, if my question is something like this, in how many different ways, listen to me carefully, in how many different ways can we arrange 4 people be arranged in 4 chairs? 4 people be arranged in 4 chairs. 4 people, 4 chairs. 1, 2, 3, 4. First person, how many different ways can you fill the first chair in? 4. Next one, 3. Next one, 2. Next one, 1. So, it is nothing but, if you observe carefully, it is nothing but what? 4 people, 4 chair, it is nothing but 4 factorial. Now, if there are 5 people and 5 chair, in how many different ways can they be arranged? Answer everyone quickly. Quickly. And how many different ways can 5 people be arranged in 5 chairs? 5 people be arranged in 5 chairs in how many different ways? How many different ways? Who is that one there? Who is that one there? Oh, there is a podchesta, the Telugu it is there, right? 1 if you type there. Now, 5 people, I'll show it for the one who said 1, okay? There are 5 chairs, guys. The 1 people, 5 chairs are there. How many chairs are there? Any chair, 5 chairs. There are 5 chairs. The first chair can be occupied in how many different ways? It can be that the first person, second, third, fourth, fifth. How many different ways? 5 different ways. Next one, 4. Next one, 3. Next one, 2. Next one, 1. In how many different ways can the 5 people be arranged in 5 chairs? It is 5 factorial. Change your answers to 5 factorial now. All those of you who answered 1 there. 5 people can be arranged in 5 chairs in how many different ways? 5 factorial. Again, quickly tell me now. 6 people, 6 chairs. I mean, how many different ways can they be arranged? They can be arranged in 6 factorial ways. 7 people, 7 chairs. 7 people, 7 chairs. 7 factorial ways. 8 people, 8 chairs. 8 factorial ways. R people, R chairs. R chairs. In how many different ways they can be arranged? R factorial. What are we doing here? What are we doing here? Cut back to the, go back, flashback. Go back to the flashback where I had what? R factorial is only arrangement. Only arrangement. What am I doing here? I am doing only arrangement. When the number of people are equals to the number of spaces, what will I be doing? I'll be doing only arrangement. I'll be doing only arrangement. Okay. Everyone understood? Understood why only R factorial is only arrangement? Everyone? Quickly drop an II in the chat box if you understood. II means it's AYE, AYE. Lazy guys who are typing I and I. Huh? I'm asking you to type 3, 6 letters. You are typing 1, 2 letters. Huh? Everyone. Drop an I in the chat box. I in the chat box, everyone. Now, next. Let's go to the next question. The next question for you is something like this. Okay. There are 3 boys and 3 girls. In a class, there are 3 boys and 3 girls. Not a class. There are somewhere. 3 boys and 3 girls are there. In how many different ways can 3 boys be arranged in? How many different ways can 3 boys and 3 girls be arranged? My question is what? In how many different ways can 3 boys and 3 girls be arranged? Quickly. Answer. Answer. Very good. Very good. Who is that? I want to see your names, man. Shrishant. Okay. Shrishant came up with the right answer. Srikant came up with the wrong answer. Dharni also came up with the wrong answer. What about others? What about others? Guys, keep your gender discrimination apart. Why do you have to discriminate the people depending upon the gender? I told you what? There are 3 boys and 3 girls. So how many people do you have there? You have 6 people there. 6 people. 6 people can sit in how many different ways? 6 factorial ways. 6 factorial ways. Why? Why? Now, think. When I told you there are R people and R chairs, what did you do? You did only arrangement. Here also there are 6 people. Do not discriminate according to their gender. Now if I ask you directly, if there are 6 people, how many different ways can you arrange 6 people in? How many different ways can you arrange 6 people in? 6 factorial ways. Did I mention you anything about the chairs, guys? All those of you who directly answered, many of you answered 6 factorial there. Did I mention you anything about the chairs? No, I did not mention you anything about the chairs. So, what is that? What is that is missing? Listen, whenever he gives you just the number of people and not the number of chairs, you have to assume that the number of people is equals to the number of chairs. Number of people is equals to the number of chairs. Now, the first scenario that will go here is all boys sitting together. All boys sitting together. Listen carefully, listen carefully. Everyone pay attention towards the screen. All boys are sitting together. And the question will remain the same. That is, there are 3 boys and 3 girls. There are 3 boys and 3 girls. All boys are sitting together. So, whenever you do not understand the question, the first thing that you got to do is write down the case. There are 3 boys and 3 girls. And all boys are sitting together. So, how will I write it? 3 boys, 3 girls. Boy, boy, boy. Next is what? 3 girls are there. Girl, girl and a girl. Yes? Now, what is the other way I can write? Boys should be together. That is the only condition that is given to me. I start with the condition that is given to me. Boy, 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 girl, girl, girl. Now, I can write like this. Girl, boy, 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 girl, girl. Yes? Or I can write it like this. Girl and a girl first, and then boy, 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 and then a girl in the end. Yes? I can write it like this. But you observe in all these cases, what is happening? What is happening? What is happening? Anyone? What is happening? All the boys are moving together. All the boys are moving together. All the boys are moving together. First 3 positions. Next, from here they started and all of them are together. Now here also they are all of them together. So they are moving as a single unit. Can I treat them as to be a single unit? Can I treat them as to be a single unit? They are moving as a pack. Beautiful. Now they are moving as a pack or a single unit. So together now, 3 girls and 1 pack or 1 unit. How many are there? How many are there? 4 are there. In how many different ways can 4 people be arranged? In how many different ways can 4 people be arranged? 4 people can be arranged in how many different ways? Yes, very good. They can be arranged in 4 factorial ways. But is it the end? No. Why? This can be boy 1, this can be boy 2, and this can be boy 3. And they can rearrange among themselves. How? The boy 2 can come in the first, boy 2 can come in the last, boy 3 can come in the first. So what can they do? They can rearrange among themselves. They can rearrange among themselves. So 3 people can be rearranged. In how many different ways can they be rearranged? 3 factorial ways. 3 factorial ways. So this gives me the answer 4 factorial into 3 factorial. 4 factorial into 3 factorial. Now, if my question is something like this, those of you who could not follow this one, let's try this one now. There are 4 boys and 4 girls and all boys are sitting together. What are you supposed to do? Whenever you do not understand the case, write the case down. What is there? 4 boys. 1 boy, 2 boy, 3 boy, 4 boy. Girls, how many are there? 4 are there. 1, a 2, a 3 and a 4. Okay, now 4 boys, 4 girls. What do? They move as a single unit. So I have to consider them as a single unit. I have written a big one here. 4 girls and 1 single unit. 5 people can be arranged in how many different ways? They can be arranged in 5 factorial ways. Next what do? Next I can write these boys can be rearranged among themselves. So how many different ways can they be rearranged? 4 people can be arranged in how many different ways? 4 factorial ways. So this gives me my answer. Now if I go something like this, 3 boys, 4 girls. 3 boys, 4 girls. What will you do? 3 boys and 4 girls. Whenever you do not understand the case, what are you supposed to do? Write them. Instead of writing them, now I'm skipping that step. Now 4 girls, 1 single unit. So I can write it as 5 factorial into these 3 boys can rearrange among themselves. So I can write it as 3 factorial. Now if I change it a little bit more, if I say something like this, if I say there are 5 boys and 2 girls, 5 boys and 2 girls, in how many different ways can 5 boys and 2 girls be arranged such that all boys are sitting together? All boys are sitting together. So what will I do? Boys are supposed to be considered as a single unit. There are 2 girls, 2 and 3, 3 people. 3 people can be arranged in how many different ways? 3 factorial ways, excuse me. Now, these 5 boys can rearrange among themselves in how many different ways? 5 factorial ways. Everyone? Shrikant, able to follow? Great one, guys. Venkatesh, I appreciate your answers in the chat box. Beautiful one. Priyanka, thank you so much. You are answering. Dharni, I can see your answers there. Nasreen, yes. Fine, guys. Anybody, any problem till here? Anybody has any doubt till here, whatever is done? Anybody, any doubt? Quickly let me know. If not, you know what to do. Quickly copy it down, take it down and let me know when you are done. Yes? Okay. Okay, where did we stop? We were done with all boys together. The next condition that we have here, listen to me carefully. Boys and girls in alternate position. What are they in? Alternate position. Okay, the question will be on alternate position. Whenever you see a question on alternate position, what are you supposed to do? How should your approach be? Now, there are 3 boys and 3 girls. There are 3 boys and 3 girls. In how many different ways can 3 boys and 3 girls can made to sit such that they are in alternate position? Whenever you do not understand what is that you're supposed to do, you should write them down. Boy, girl, boy, girl, boy, girl. This is alternate. What is the other way you can write such that boy and girl are in alternate position? Now I started with a boy here in the first place. Now I can start with a girl here. Girl, boy, girl, boy, girl, boy. So what did I do? I can either start with a boy in the first place and the conjunction that I'm using, or I can start with a girl in the first place. What is that I can do? I can start with a boy in the first place or a girl in the first place. Now, these 3 boys, boy 1, boy 2, boy 3, 3 boys can be rearranged among themselves in how many different ways? 3 factorial ways. Now, and these 3 girls can be rearranged among themselves in how many different ways? 3 factorial ways. 3 factorial into 3 factorial. Yes, or represents what? Addition operation. Or represents addition operation. These 3 girls can be rearranged in 3 factorial and these 3 boys can be rearranged in 3 factorial. So what does that give me? 2 times of 3 factorial into 3 factorial. 3 factorial into 3 factorial. 6 into 6, 36, 36 into 2, 72. Yes, we can do that as well. Now if I ask you something like this, if there are 4 boys and 4 girls, boys and girls are sitting in alternate position, will you be able to solve it? Yes, you can obviously solve it now. What is that you need to do? You have to start thinking. Whenever you do not understand, either you place the case there or start thinking. Now, what is that you can do? 4 boys can be arranged in how many different ways? 4 factorial ways. Okay. Now, and these 4 girls can sit in how many different ways? 4 factorial ways. But they can either the boy can sit in the first place or the girl can sit in the first place. So 2 here. Yes. Srinath, I will take up that in a while. Okay. Now, if there are 5 boys and 5 girls, answer me quickly. 5 boys and 5 girls. What will be our answer? Alternate position. 2 times of 5 factorial into 5 factorial. Many interesting questions coming more now. Now listen to this one. This says 3 boys and 4 girls. This says 3 boys and 4 girls. Whenever you do not understand, what are you supposed to do? Boy, girl, boy, girl, boy, next girl. How many boys am I done with? 3 boys. How many girls am I left with? 1 girl. Where do I have to keep her? I can keep her here only. If I keep her here, will they be in alternate position? Boys and girls? No. They won't be in alternate position because the girl will come next to a girl and it will violate my condition. So what I do to do? I can place her in only one position, that is here. Will there be another case? No. So what will this give me? These 3 boys can be rearranged among themselves in 3 factorial ways, whereas these 4 girls can be rearranged among themselves in 4 factorial ways. Now if I ask you again now, this time what am I doing? I will say there are 5 boys and 6 girls. 5 boys and 6 girls. What will be your answer? Everyone, what will be your answer? Answer will be simple. What is that you need to do? There is only one case. One case. What will happen? Very good. 6 girls can rearrange themselves in 6 factorial ways and 5 boys can rearrange themselves in 5 factorial ways. Now, I will move a step ahead now. I will move a step ahead and I'll ask you something like this. There are 3 boys and 5 girls. In how many different ways they can be arranged? Whenever you do not understand, what are you supposed to do? You write it. Boy, girl, boy, girl, boy, girl. Okay, how many boys am I done with? 1, 2 and 3 boys are exhausted. How many girls am I left with? 2 girls. 1 girl I can place it here. There is another girl. Where do I place her? I cannot place her anywhere. If I place here, it will violate the condition. If I place here, it will violate the condition. Now, there will be how many different ways? You can place in 0 ways. 0 ways. Now I have a note here for everyone. What does the note say? Note say, when the number of boys are equals to number of girls, number of boys are equals to number of girls, what will happen? You will have 2 cases. You will have 2 cases. Look, a number of boys are equals to number of girls, you will have 2 cases. Number of boys are equals to number of girls, you will have 2 cases. Number of boys, 2 cases. When the difference between boys and girls is equals to 1, how many cases will you have? You will have only 1 case. You will have only 1 case. You will have only 1 case when the difference between the boy and the girl is 1. So you will have only 1 case. You will have only 1 case. But as the difference between boy and girl is greater than 1, how many cases will you have? You will have 0 cases. You will have 0 cases. Whenever there is a difference of more than 1, in the alternate case, whenever the difference is more than 1, there will be 0 cases. Fine. Everyone able to understand? Till here, anybody any doubt? Now, let's move ahead. Let's move ahead. We are done with 2 boys sitting together, boys and girls in alternate position. Now, I'll tell you something like this, and it is very important. Okay. And it says, boys and girls in alternate is done, boys together. No 2 boys sitting together. I'll tell you, no 2 boys are sitting together. Okay, no 2 boys are sitting together. There are many interesting questions going to come. So stay tuned. Just listen to me carefully. Okay, there are no 2 boys are sitting together. No 2 boys are sitting together. And after the arrangement part, we'll stop for the day. So just listen. There is this probably will be the last case that we will be dealing today. And so now this one here. No 2 boys are sitting together. What does this mean? Pay attention. Pay attention. No 2 boys are sitting together. There are 3 boys and 3 girls. Class. There are how many boys and how many girls? There are 3 boys and 3 girls. What is that I can do? No 2 boys are sitting together means what? Means what? What is the prerequisite? What is the prerequisite? What is the condition for no 2 boys to sit together? Start thinking. If you want no 2 boys to sit together, it also means that there must be 1 girl between 2 boys. There must be 1 girl between 2 boys. Yes. If there is 1 girl between 2 boys, will it ever be possible for 2 boys to sit together? My question is, will it be possible for 2 boys to sit together if there is 1 girl in between them? No, it is never possible. So first step that I will do is, I'll start placing my girls. I'll start placing my girls. Okay. Now later what I'll do is I'll start create spaces between them. I'll start creating spaces between them. Now, if you observe, these three girls can be rearranged among themselves. In how many different ways? In how many different ways? 3 factorial ways. 3 factorial ways. Now, number of chairs are greater than number of people. There are 3 boys and 4 chairs. So, when the first boy walks in how many different ways he can sit? He can sit in 4 different ways. Second boy walks in 3 different ways. Next boy walks in 2 different ways. Yes, able to understand everyone. Able to understand. Anybody, any doubt? There must be a few doubts here. I'll address the doubts also. Look, what is that? You must be having a doubt, something like this. Something like this. That why did I not write that case? 3 boys and 3 girls. I can write this case. Look, boy, girl, boy, girl, boy, girl. Next way, or you can write it as something like this. Girl, boy, girl, boy, girl, boy. Now, should I stop here? No. That is the reason I did not write. Because no 2 boys are sitting together. No 2 boys are sitting together. But girls can be sitting together. Girl and a girl, boy. Now again a girl and a boy. And a boy will come here. Yes, still it is functional. Still it is functional. Like this, how many cases can I write? I can write many cases. So I cannot write the cases this way and go ahead. I cannot write the cases this way and go ahead. So what will I do? I'll rather place, whenever I see a question where it says no 2 boys are sitting together, what will I do? I'll start placing my girls first. I'll start placing my girls first and then create spaces in between the girls. And then create spaces in between the girls. And once the spaces are created, now these 3 girls can be rearranged in 3 factorial ways. And when the first boy walks in, he can sit in 4, next boy 3, next boy 2. Yes? Yes? Following it? Understanding? Now, why have you created an extra space? There are 2 doubts commonly asked. First one is this, why didn't you write all the cases? Second one is, why have you created one extra space? Now, look, this is the condition that we have here. Girl, girl, girl and a girl. Everyone pay attention. Here is also there. There are 3 boys. Let's say, where do you want me to fit the first boy? Let me say I made the first boy sit here. Okay. Now, later the second boy came. Boy 1 I'll write. Second boy came, he came and he sat down here. Third boy came and he sat down here. This space is vanished. It is nothing but a condition, something like this. Boy 1, girl, girl, boy 2, girl and boy 3. This is a probable position that the boy can take. If nobody occupies it, it is vanished. It goes away. So this case is similar to the case that we have seen here. Boy, girl, girl, boy, girl, boy. Yes? Yes or no? Yes or no? Everybody, all the 2 doubts. The 2 doubts that you had in your mind, are they cleared? Now can we go ahead with the question? The next question says something like this. If you were able to understand, yes, type an yes or an I in the chat box so that I can understand that you have understood. Okay. Now let's go with the next question that we have here. It says something like this. Let's say there are 4 boys and 4 girls. In how many different ways they can be arranged? This is that. No 2 boys are sitting together. What will you do now? What will you do now? 4 boys and 4 girls. So I'll quickly place my girls, girl, 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 girl. Next step I'll do is create spaces between them. Once the spaces are created, I can see that 4 girls can be rearranged in 4 factorial ways. Into, when the first boy walks in, he can sit in 1, 2, 3, 4 and 5, 5. Next boy walks in, he can sit it in 3. Next, 4. Next one, 3. Next one, 2. There are 4 boys, they are done. They are done. Yes. Now if I ask my question something like this. If there are, let's say, 5 boys and 3 girls. 5 boys and 3 girls. What will you do? What will you do? What will you do? Now, start thinking. Girl, girl, girl. How many spaces did I create? No 2 boys are sitting together. 5 boys are there, 3 girls are there. 3 girls are placed, created spaces between them. When the first boy walks in how many different ways can he sit? How many different ways can he sit? Okay, 3 girls, 3 factorial. I have got the answer there, but for everyone, 3 factorial. Next, what will happen? Next, what will happen? When the first boy walks in, he can sit in 4. Next boy, 3. Next boy, 2. Next, spaces are full. Now what will happen? They'll come next to each other. They'll start coming next to each other. Yes or no? 3 or one more is there, right? 1. So how many boys are done? 1, 2, 3, 4. 4 boys are done. One more boy is left out. He'll start occupying a position next to the boy. He'll start occupying a position next to the boy. So this cannot be. This is 0. This is 0. Yes, everyone? Everyone? Pakka? Pakka? Everyone understanding? Now, if the number of girls are more comparatively, if number of girls are 9 and there are 4 boys, what will happen? What will happen? 9 girls are there. 9 factorials, they can be arranged. How many spaces will be created? Plus 1 space will be created. Plus 1 space will be created. Yes or no? Start thinking. If there are 9 boys, I will start creating spaces between them. 1 extra will be created. 10 spaces will be there. When the first boy walks in how many different ways can he sit? 10 different ways. When the next boy walks in how many different ways can he sit? 9. Next, 8. Next, 7. Stop. Because I'm done with the number of boys. I'm done with the number of boys. So it is 9 into 10 into 9 factorial into 10 into 9 into 8 into 7. Yes, everyone able to follow? Yes or no? So this is my last question for the day. Did you guys follow? Anybody has any doubt with respect to whatever is done in the class today? Did you guys find it fruitful? Did you guys find it fruitful? Yes or no? Yes to yes, no to no. That's fine. Did you guys find it fruitful? And yes, if you found it fruitful, guys, please do like, share and subscribe our channel, and also spread a word among your friends that such and such thing is happening where you can avail a course for free, so that it will be helpful for us also and it will motivate us to work, do more work like this. Okay. Thank you one and all. Before leaving, copy whatever is on the screen and then leave. You have been a wonderful, wonderful class. Thank you so much. Hope to see you soon. Take care.